Hope that everybody had a fantastic and restful and relaxing spring break. You guys may have noticed that the scenery around me has changed, and that's because I am in a new location. So I am back home at my parents' place in Colorado, hanging out here for a little while during quarantine. So I'll be recording videos from here. A quick little refresh. I wanted to give you guys a little detour of what I did over spring break. So I drove across country from New Orleans, Colorado. So this is somewhere in Texas, looking at the sunset. This is Capulin Volcano National Monument, a really cool spot if you ever are driving in between these points. After a while, I finally got to see some mountains, and then I arrived home, safe and sound, to my teepee, which is where I live. And in fact, this is a teepee. No, it's not actually. I'm not in the teepee, but this is in my parents' backyard. And this is also in my parents' backyard. This is the view from our house, just a little hike over this hillside. And it's really pretty. So I've been hanging out here doing a lot of kind of hiking and trouncing around. Did some archery shooting with my brother. Here's me hanging out up on our garage where we recently installed some solar panels. My parents did. They got chickens a few years ago, so I was hanging out with those guys. And in the chicken yard, there's 10 of them, so we have a lot of fresh eggs, which is kind of cool, and they're always fun. I did a little bit of skiing, so skied up to the cabin, which I think I've told you guys about, up in this little town called Fulford. Skied with my buddy Steve, at least 6 feet apart. Don't worry, it's being plenty safe. And this is the view of the mountains from Fulford. Those are the same mountains you can see from my parents' backyard, just a little bit closer. You can see how much snow there was. There's about 2 feet of snow on the ground still, which is pretty darn awesome. Made it for some really good skiing. We were also hanging out on the deck, and there's this fox that just wandered up. Came walking from the woods and sat down right next to us for a little while on both sides, about 10 feet away, and just kind of hung out, which was really cool. Got to do some rafting too. This is my little raft on the Colorado River. It was a really flat section. I was doing some exploring. Saw this cool old car that was stuck in the bank, and this little fossil, some kind of a nautiloid, little spiral fossil there, which was really cool. But the main point of this rafting trip that I did just a couple of days ago was to look for some hot springs that I had done some research on in the area, but never actually been able to check out. And so there are about 3 big hot springs and then a bunch of other smaller hot springs. And it was really cool. It was about 98-ish to 100 degrees coming out, and they were pretty gross, so you wouldn't really necessarily want to sit in them. Had a bunch of algae growing in them, but they were really cool. This one especially, I was kind of crazy. It was only about a foot deep, but it had this kind of silt that was bubbling up in the bottom. And I was curious, like, kind of why it was bubbling up like that and what that meant. And I was curious to, like, how solid it was. So I actually stuck a stick down in there and checked it out. You can see it kind of bubbling there. And I could stick this stick down about like 4 feet before I hit anything kind of solid. So it was like this weird, like, mud bath thing, which was kind of interesting. So that's what I've been doing with my free time. And then now spring break's over and we're back to the grind. So here's what we got going on. A few things that I wanted to talk about. Like I said, I hope you guys are doing well. And I want to talk about some of the feedback that I got from you guys from that survey, and some things that we are going to change and some things that we're going to look forward to. But one thing I want to say is please make sure that you're saving your previous projects, right? So in Tinkercad, if you actually go, I see a lot of projects being turned in with the names that it auto-generates, which isn't necessarily good, because what I will do a lot of times is if there's a piece of code or a design or a setup for something that I want to use later, right? I'll go to my saved projects and I can click on them and look through what the code was and what the setup was, so that I can reference that, right? It's like you're almost building your own kind of book on this. And that way you don't have to go back to the videos or go back to that other stuff. You can actually just find the work that you've previously done to help you do something. Right, so please make sure that you're saving your work on here. I probably should have mentioned that sooner, but that's just kind of a good thing to do. Based on the feedback that I got from you guys on the survey, I'm going to try and shorten the assignments and also kind of deepen them, go a little bit more into the coding and what's actually happening there. I'm also going to move the due dates to the next day at midnight, right? So essentially the day before the next class. So you guys will have like a full, essentially 2 days to do the work and turn in. I would still recommend trying to do the assignments the day that they're posted, just like being in class, right? That's the idea behind it. And I'm going to start taking off points for late work without proper communication, right? So if you have something going on, if you've got issues, internet connectivity, some kind of anything going on with your family or your home life, please make sure you communicate that with me. Communicate kind of roughly what's going on, when I can expect it to be done, just so that we're in touch, right? If I don't hear that, then I assume that you're just not doing your work, right? Or you're slacking or procrastinating. So just make sure you're communicating, and that's long and short. I'm very flexible with the due date still. It's just try and do it and try and be communicative about it. I'm going to keep trying to make things as interesting as possible, but there's still an aspect of school to it. So here's kind of what we've been covering so far, and we're kind of trying to wrap up our understanding of our different inputs and outputs, right, as well as how to code. So our inputs that we've learned so far are buttons, right, so kind of this touch sensor, potentiometers, right, which sense rotation, temperature sensors, and then photoresistors, which kind of sense the amount of light. So those are the inputs that we have, right, the sensory inputs that we can use to respond to. And the outputs that we've learned so far, the reactions that we can have, is we can turn on lights, right? We can just turn them on at one level, or we can kind of fade them in and out, or turn them on to a specific level using this pulse width modulation. And then we also have buzzers or speakers, right? Which is the piezo, so we can actually make a sound, right, or a buzz. Now we can also use these in real life. We could use these piezos as an input to sense sound vibrations, but unfortunately in the Tinkercad it doesn't allow us to set them up that way. But in reality, it actually can. So those are a few of the things that we've learned so far. And we've still got a decent bit to learn. We're going to be talking about servo motors, DC motors, motors with encoders. And encoders measure the number of rotations that a motor is doing, right? So we can actually measure that and track rotational distance. And then ultrasonic range finders, right, which measure distance. So those are the kind of last four things that we're going to be covering there. And I'm also going to do a little bit more one day of wrapping up on coding, with Arduino. So some of the main commands and codes that we've learned so far. So a little summary of that. On the horizon, we're going to be using this Arduino system to try and solve or create and design some different solutions to projects, right? So I've got a bunch of different projects I'll post, and you guys can look through this at your leisure if you want to kind of start planning or thinking. But just some different projects that you guys can do. Ideally, we'd be able to physically build these out, but instead we'll be kind of creating a design drawings, and then coding out what it would end up looking like, right? So you guys can check that out. And so that's what's coming up into the future. But today, our main lesson today is we're going to be talking about servo motors. That's really our goal today, is just to understand what these servo motors are and how they work, right? So I have posted this video, and I'm going to post this video on Classroom, but I just kind of wanted to play through. This has some nice little pieces about what a servo motor is, right, and how they work. So they actually kind of turn like this. It's constantly kind of sensing it's where it is in its position there. They're used in all sorts of things like remote control cars or toys, robotic arms, those kind of things. Any kind of design thing where you want to set something to a specific position, so almost like humanoid-like things. This is what the inside looks like, and this is what it has. I'll talk a little bit about this here. Essentially, we have this little plastic piece on the outside, which we can attach things to, and that's the piece that actually turns. The entire thing is driven by this DC motor, right? So we've talked a little bit about motors. You guys know how those work. We've got a gearbox in here, right, which essentially trades off, gives us some more torque in return for this not turning as far. Okay, but so these servo motors actually have fairly decent torque. We've got a control circuit, and we have a potentiometer. Right, and so servos, they can only turn a certain range. They don't do a full circle around. They can only go from typically from 0 to 180 degrees, right? So 0 to 180 degrees. So that's the range of rotation that they have, and that's kind of determined by the potentiometer that we have in here. And how that actually works is kind of interesting. We have this pulse width modulation. We use that to do that. So we send out these pulses, right? These output pulses, and we send them at 50 pulses a second. And depending on the size, right, of the pulse, the amount of time that the pulse is sent out for, right, that'll set the angle that the servo is going to be at. So if it's sent out for 1 millisecond, it'll be at 0 degrees. If the pulse is sent for 1.5 milliseconds, it'll be at 90 degrees. If the pulse is sent out for 2 milliseconds, it'll be at 180 degrees. So depending on the length of this pulse that we send out, the motor will set itself to a particular position, right? a little complicated. You guys don't need to know the nitty-gritty of it, but I want you guys to understand that this is how we're actually controlling the motor, right? We send out these pulses at regular intervals, and that sets, based on that potentiometer that's hooked up to that DC motor in the servo motor, we can set that arm to a specific degree, right? And so that's what we can actually control. So it's pretty cool. So if we look at what they actually look like in here, if we go into Tinkercad, right, you can kind of scroll down here, and there they are, little servos, just like that. So you can drag and drop one of those into your project, and you'll notice that they have these three kind of pins coming out of them. One is the signal, one is the power, and one is the ground. Okay, so I'll go ahead and connect my power to my power, and I'm doing this without a breadboard. You guys could always put in a breadboard if you guys want to do it. So I'm going to go to 5-volt power, and since that's power, I'm going to make it red. And then I'm going to put my ground to my ground, and ground I'm always going to make black. Then the signal, right? Like I said, in order to control the servo, right, we need to have this pulse width modulation signal. So we're going to be using this pulse width, which is represented with this little kind of squiggly there. Those pins can have the PWM, the pulse width modulation. So I'm going to put that out on number 9. Right, so now I've got my servo actually set up, and so now I could actually put out code to control and tell the servo what position to set its arm in. Right, and this code might look something like this. This is about the most bare bones code that you would need to run a servo. You can run them without including the servo library, but it's nice, and the video actually talks about how you can run them without the servo library. But it's really nice to actually have the servo library. It makes our coding a lot easier. So that we don't have to worry about setting those pulse widths that we're actually sending out. So in order to put in the servo library, what we do is this hashtag include and then servo.h, right? And so that's referencing this servo library right here, which is set up by Arduino. And this servo library allows us to control the servo motor and the position that it's going to be at, okay, somewhere between 0 and 180 degrees. Now I wanted to point out one thing it says on here, is if we, with the circuit here, if we want to do more than one servo, right, they draw a lot of power, a lot of voltage, a lot of current. So what we need to do is we need to do a separate power supply, right? We're going to learn how to do that when we set up DC motors, because they're the same way. Today, we're just going to focus on using a single servo, so we're not going to have to worry about that. But that's something to keep in mind. But this has all sorts of information on this library. It has a few kind of example projects. This knob one is going to be similar to our homework, which is going to be the mood cube, right? But then there's also this other one, sweep, which you guys can optionally do for homework too, which sweeps the shaft of the servo back and forth in a continuous way, right? So that's kind of a fun extra challenge if you guys would like to try that. The two main functions that we're going to use in this library are going to be the attach and the write. Okay, the attach just attaches the servo and tells the Arduino that we have a servo at a certain pin, whereas the write actually tells it what angle we want the servo to be at. And you guys can learn more if you would like by clicking on those. It'll tell you some information about that. Okay, so if we go back here, what I've done is I've included my library using that section of code, and then I need to create a servo object. So I just have servo space my servo. Right, and that's how you can create a servo object. Is you do servo, my servo, and the my servo just represents the name. So if I'm referencing that servo, okay, then it's going to be my servo. Right? I could have named it servo 1, or I could have named it Peter, right? But to keep it simple, just my servo. Okay, so I'm creating my servo object, and then in my setup here, say, okay, so running once. Right? Remember, in the setup things, just run once. I'm going to do my servo, so I'm going to reference the servo object there. I'm going to attach it, right, to pin 9. So what I'm doing here is I'm saying, hey, pin 9 has a servo on it, right? And that servo is called my servo. Okay. So pin 9 has a servo on it, and then within the loop, so the thing that's going to repeat continuously, I have my servo, right, which is the name of my servo, dot write. And this write is setting the servo position, okay, from 0 to 180. So the value in here could be anywhere between 0 and 180. So let's say I wanted it to be 60, right? That would set it to 60 degrees, right? And then we have a little delay, so we're going to wait for the servo to get there. So if we start the simulation and see what this looks like, as it initializes, There we go. Boom. It has set to 60 degrees. All right. Now I could stop that. I could mess around. I could say, hey, I want this to be at 180 degrees. And we can start the simulation and see what happens. And it'll set to 180. Right. I could also set it to 0 degrees, right, and see what that looks like. And voila, it sets to 0 degrees. Now you'll notice it's just a little bit offset. I'm not entirely sure why that happens, but it's the way that it is. So that's the way that the servo works. Now let's say that I wanted it to go, let's say I wanted it to go from 60 degrees, and then I wanted it to go to, I'm going to copy and paste this. Let's say then I want it to go to 20 degrees, right? And then I want it to go to 120 degrees, right? Then it could run through, and these delays, right? It would be delay 15 milliseconds. So maybe let's expand that a little bit. Let's make it 100, so 1/10 of a second. You can make those whatever values you want, right? But now if I go ahead and start the simulation, what it'll end up doing is it should start at 60 degrees, right? Then go to 20 degrees, and then go to 120 degrees. And it'll keep looping through that. Now it's actually, it turns out it's looping too fast. It doesn't actually have time to get there. So let's go ahead and increase this time interval to give it actually a decent amount of time to get there. And hopefully that ought to fix it up. There we go. So now with that time interval, it's going from, there you go, 60 to 20 to 120, right? Just like that. So now I'm controlling the servo using this code, right? Using my Arduino to actually code and control where it goes. Now this is, once again, there's no inputs to this. This is just an output, right? But let's say that I wanted to put an input on this. Let's say that I wanted to have a simple button here, right? That if I clicked that button, then it would go through this process. Let's say I wanted to go from 60 to 180 to 120, then back down to 60, right? To make it a little bit more of a broad range there. But let's say I wanted to include a button. Well, let's say I don't recall how to do a button, right? Well, but I remember at one point in time, we did something with a button, right? In fact, lesson 2, we talked about having a simple button input. So what I could do is I could open this up to Tinker, and I could reference, right, what I've already done before, which is useful because I can actually just copy the code verbatim, paste it into my new document, and then I'm good to go, right? So pretty straightforward. We'll see. There we go. So now I see I have my button here, and I remember that I had to have power going through, and then if I press the button, it has to have a way to ground, and it also has to have a way to one of these digital pins, right? Now the way that these buttons read is they read either high or low, right? They read either not pressed or pressed, right? So I need to have a setup like this. And then I need to have a resistor in here. I have a 10 kilo ohm resistor, so I can even reference that, right? So what I can do is within my, I know a few things that I can add. So I had my variable named button, which is representing pin 2. Pin mode, pin 2 is an input, so I need to set up my pin mode. And then I need to have my button state, and I need to read it. And then if, right, my button state is pressed, then it's going to write this LED. So I can do that same thing, right, just over here, right? So if I add in a button, where are you at? There we are, push button. Right, I can add this in, and I know I need to have one side attached to my power. This is where it would be nice to actually have a breadboard. Say lobby. So I'll go from power. One end is going to go to power. I'm going to make that red, of course. And then one end is going to go to ground. Right. But the route through ground, actually, let's go ahead and just reference this guy over here. So the route through ground is going to be through, right, a 10 kilo ohm resistor has to be the route to ground. Okay, and on that same route, I'm going to go to a pin. So let's say pin 2. So I want to go here to pin 2 on this side, but I also want to go to ground, and I want to go to ground through a resistor. I want that resistor to be 10 kilo ohms. And that's going there to ground. And since they're going to ground, I'll go ahead and make them black. All right, so now I have my push button set up. I can go back to my code. And I know that within my setup, right, I need to go ahead and name pin mode, right, as an input. So pin mode input, Control C, and Control V. Right, and I want the button is pin 2. So pin 2 is an input. Okay. And then if I go back here, I need to go ahead and name button state, right? And that's just whether or not it's whether or not the button has been clicked, right? So that's checking to see if the button is pressed or not. And so essentially, if the button state is high, then it'll turn on. If the button state is low, then it'll turn the LED off. So here, right, essentially what I want to do is if this button state is high, I want it to run that setup. I want it to go through that. And if the button state is low, then I want it to do nothing, right? So let's go ahead and create a button state variable as well. So I'm going to go ahead and copy that, Control C. And that's going to be a global variable, so I'll go ahead and put it up here. So now I can go ahead and put in here button state is equal to the digital read on button, which is pin 2, right? So button state is equal to the digital read on pin 2, right? So if pin 2 is reading high, then the button state will be high, right? And if it is not pressed, then it'll read as low, right? So then we'll go ahead and have if button state is that, else then we're going to do low. So I'll just copy this whole segment here.